Welcome back to wortheffort Woodworking. In my last video, I made an English square using predominantly only hand tools. The only power tool I used was a bandsaw, and that's just because, well, I wanted to. So I did that one to show people that you can make stuff like this very simply with a limited set of tools, because really the only woodworking techniques you saw me use in creating this was a little layout skill and being able to saw the line. That was it. I mean, it is a very simple project that is a great skill builder. And I didn't do a full tutorial on it using hand tools, mainly because Christopher Schwartz, he does a really good job of this, and this is kind of a staple of his in teaching and demonstrating stuff, so I just didn't want to tread on his feet. The joinery I used on this is quite a bit different than what he does in his product, and I believe I did different techniques than what he uses to teach with. So I didn't feel too overly rude about making the same product and putting it in a video form. You can see his version on the Woodwright shop. A really great video. Go check it out. I'll probably put a link down below. Anyways, I'm about to do a small batch production run, making a whole bunch of these to sell online. And this is kind of the third item in my layout kit of tools I present to y'all to help subsidize the school. The first being my little cheap dovetail marker, the second a French square, and the third is a rough layout tool that I use. And I also helps out with glue ups, because if you've ever done a cabinet, you can kind of clamp them here to get that perfect 90 degrees. Anyways, in a production run, there is no way I would do all that hand tool work and think that I could present this in a package that would be affordable to people. So obviously I'm going to be bringing power tool concepts, production run concepts into the process, and that's what we're going to be discussing today. I will be throwing a lot of tips and tricks and opening up discussion paths in this presentation. I'm also going to try to show you different ways that if you're in just a small shop that does depend upon power tools, maybe you might do different joinery techniques than I'm going to use in my mass production, simply because it would work better in one-off situations in that hybrid style shop. So, come along and let's batch out a bunch of English squares. Now, when you are working with strictly hand tools or in a small shop and just making one item, your material selection, well, it's just a lot more flexible. Like in that video, I basically just picked up an offcut from when I was creating turning bowl blanks. It was straight off a chainsaw, and I liked the color in it, the figure in it, the spalting in it. It just looks cool to me. So that's why I picked it. And as far as dimensioning, all I really had to do was flatten one face of it, and then I could get 3 identical boards out of that one block of wood, just ripping it on a bandsaw. I could have done the same exact thing using that flat edge and a marking gauge to mark out 3 identical lengths and cutting it with a handsaw. And if you're only making one of them, even doing the handsaw method would probably be quicker than what I'm about to do in setting up a lot of tools and doing a lot of dimensioning with power tools. But if I was doing a bunch of them, obviously the power tool method would be quicker, because I'm going to be basically setting up a power tool and making 100 or 200 different pieces of stock for this project all at once without changing the settings. And because of that, material selection becomes important, but in a different manner. Now, it is always going to be cheaper to buy rough stock. Now, the place I get my stock, they do something called skip planing, where they just run it over real quickly just to get off the rough stuff, so that you can see the figure a little bit more. And it does reduce the material a tad bit, and you actually pay more for that service. Whereas if it was all rough, I wouldn't be able to see if there was any curl, like I have a little curl right here coming through on this particular board. Now, the project we are going to be doing, it's generally going to end up being a 1/2 inch thick. That's traditionally how they did it. I always make mine a little bit thicker just because I like it that way. So in theory, I could have bought 5/4, which is basically 1.25 inch stock. Now, as it's dried, it comes down a little bit, but I've always found the price difference between 5/4 and 6/4 to be so close that I just go ahead and get 6/4, especially when I'm buying maple, because all of my turning stock for things like tops and honey dippers and all that kind of stuff comes from 6/4 maple. So if I have a board that has a blemish in it or something like that within that section that I have to create, well, I'll just turn that into a turning blank where I only need smaller section out of it. So I can buy a longer board with nice straight sections in it, nice clear straight grain that might have a few blemishes here and there, and work around it in this particular project. If I didn't have that option of reusing the scrap stuff for something else, I might have not been able to buy as much material because I couldn't find as much clear stock, and my dollar per investment of board foot would be a lot less because I'd be losing a lot of stuff. Now, unlike when I made just that single square, where this dimensioning process started with flattening the entire face so I could get the thicknesses out of a single board, I'm looking at this one, and my first step is going to be cutting them all to length. My squares are going to be about 18 inches, so I'm going to find 20-inch sections, as many as I can, within each one of these boards. I'm actually going backwards due to the processing techniques I'm going to be using and the material I have. So I start by setting up my long miter saw station. Now, dimensioning wood in this order, I'm not going to tell you is the safest thing in the world. You've got to take assessment of the risk and take the responsibility of your actions. The reason why I say that is a chop saw is kind of designed for stuff like 2x4s and stuff like that. They're pretty uniform, pretty square. This is a rough board. It has some twist in it. It has some cup in it. So whenever I bring this saw blade down, as soon as you release tension, it's going to want to fall, and it might pinch on the blade, causing kickback, which is kind of scary. Or the fact that as you're cutting along, it might want to wander. So I've got to somehow secure it, and I would rather have it cup down than cup up. So this one right here has about a finger's worth of gap right there. I'm going to flip it for the simple reason that I know that this section right here is now touching there. So if it splits, it's going to fall this way and likely not pinch on the blade. How do I take care of the cupping? Well, honestly, I'm just going to hold it. And that's not the safest thing to do. But the advantage here is the proper way of handling this would be to flatten this entire board. That was a lot of cup I showed you. I would have to remove quite a bit of wood on this corner and on that corner. And it might be so much wood that I end up not being able to get a ½ inch out of each side. So I'm trying to maximize my yield by taking a little bit of a risk. So the first thing is just to mark out your lengths. And personally, I like a yardstick compared to a tape measure in this kind of situations. I'm marking them at 20 inches. Knowing that that'll give me a little bit longer of a board than I actually need. And in the layouts, I'm taking into consideration major defects like that right there. And now that I got my sections, I can see that I can basically divide this board in half. And when I'm cutting longer boards into shorter stock, I like to do that one. Cut them into much shorter distances. If you just come in from the edge a little bit, you still got this unwieldy mess. Plus the fact, every time you cut it in half, you're cutting that twist in half. If I just cut it off of the end, I still have a longer board that have to deal with a lot more twists. So my suggestion, if you're doing this slightly dangerous technique of cutting rough stock on a miter saw, make your measurements, get your best sections of wood you need, and then start in the middle and work your way out, cutting it in half and half and half as many times as you can. So here's that first board I just cut on that miter saw. Notice how these shorter lengths have so much less twist involved. Yet even this little amount would scare me to put it on a table saw. And I know that I'm going to be cutting this out into 2.5 sections. So the next step for dimensioning these, I'm going to do on the bandsaw. Because even though it's not great, that little bit of movement will not cause me physical harm if something goes bad on the bandsaw. Now, I've said it many times that I think the bandsaw is like one of the first major power tools any home shop or a production shop should be getting, much more than the table saw, and it does go against the grain. But you've seen when I did the hand tool English square, I use a bandsaw for a lot of the work that I would have done with just a big handsaw. It's just a little bit quicker, more easier. And it doesn't take up much setup. I only pay about $13 for these blades, so if I mess one up, it's not that big a deal to me. And you can get blades like this at pretty much every metropolitan area has some kind of professional shop where they buy these by the mile, and then they just cut up and weld however long you need them to go. And right now my only objective is to get blocks of 2.5 inches wide in long lengths. Now if I were to take this board directly to a table saw, it would really be dangerous. Rough stock should not be done on a table saw. And let me explain why. While this edge looks straight, there's warp, there's twist into it. And if you run an edge along a fence, which you should always do with a table saw, well, this distance right here is likely longer than that fence. So while I might start with it right on the edge right here, as I progress over, if there's a bow on this side, it might start kicking the board out into that blade. Very dangerous, causing the blade to flex, burn, all that kind of stuff. Or possibly even worse, if it is cupped, I might ride that other end out and it will catch on the back of the blade, get caught, fling back towards me, and you end up with kickback. Well, the advantage of a bandsaw is its blade is designed to flex. So if any of that happens, it will move a little bit. It can flex a little bit, and the power is going down, not back at me. So this is infinitely better, especially in situations like this where you're dealing with rough stock. And I also have stock where I have imperfections. So I can really easily just move my fence over, make sure, cut that out, cut out this section, making sure I leave about 1.5 inches so I can get my turning blanks out of it, and move along and just treat it very, very easily. This we are at is a rough cutting stage. It is not going to be the last time a tool touches a board, so I'm not worried too much about it. I'm just getting it close to the dimensions so we can refine it with the more finer tools. Also, wider boards like this oftentimes are flat sawn, which means you're going to have nice straight grains on the outsides, but in the middle you're going to start getting these cathedrals. And if I'm trying to make a very elegant square, I might want the consistent grain pattern without the cathedrals in the individual parts. So a lot of times what I would do is I will take from the sides and then leave the middle as if it's extra. Now that we've got all that big stack of lumber milled down to 2.5 inches wide, and because we went on the bandsaw, we now have a pretty 90 degrees and fairly straight edge, even if they were warped to begin with. But about that warpage, I want you to take a look at this stack. I mean, when those boards were in their full size, they were warped, twisted, all that kind of stuff. There's this idea that when you're dealing with rough stock, the closer you rough it down to the final size, never to the exact size, the final size, all those issues tend to go away. A big board might be warped a whole bunch across it, but when you make it narrow, that warpage practically disappears. A long board might be bowed a whole bunch, but when you take a little section of it, that bowing is not that big a deal. So the smaller you get it, the easier it is going to be able to refine it and the less waste you're going to have. Out of those 6 large 12-foot boards, this is what I've got left. Most of this can become tops or magic wands or finials or anything like that, because hard maple is one of my favorite spindle turning materials. So very, very little waste involved. Now, in getting them into exact dimensions, I do want to mention that most people will get them close to what they want as their final dimension, let it sit for maybe a week like that, and then reprocess it, because they're allowing the wood to get accustomed to their environment, or to maybe relieve internal stress or something like that. I bought this material at a warehouse, an outdoor warehouse, about 30 miles from me. I'm working in an outdoor warehouse. No AC, no nothing. So if this stuff hasn't been acclimated yet, it ain't going to be acclimated. So in the next steps, I'm just going to go straight to the finished dimensions as close as I can get. Now the next step I have to do is get 2 half-inch boards out of these blanks right here, half-inch thickness wise. And in a power tool shop, you have a couple different options. I could go over to my jointer, flatten one edge, and create a square on the other so that it would sit on my table saw flat and go against the fence smoothly, and then just rip them in half on the table saw. And typically a table saw would be a lot faster in ripping this long things than something like a bandsaw. But I would have to do those 2 steps on the jointer before I even got to the table saw. Because remember, this is still rough lumber. And the fact that once I split these, there's a chance I would have removed tension on it, so there might be some movement where I would have to go back to the jointer and re-flatten, re-square it. I prefer to use the bandsaw in this situation, because when I roughed it out like this, I had my bandsaw set up at a perfect 90 degrees. So this right here is pretty much 90 degrees. And even if you had some cup or bow right here, the process of putting it through the bandsaw greatly diminishes it. So you'll end up with fairly flat, straight boards. So I will set up the bandsaw just to rip this rough board in half. But I'll tell you, I also use a table saw. You can see right here, I have my bandsaw and my table saw set up, and I expect that I will be spending the next couple hours dimensioning these in half. What I will do is I will look at it, and if I can eyeball it pretty straight, and I understand that the bandsawed side down here is pretty much 90 degrees, I will run it through the table saw, because the table saw is just a lot quicker. But if I find a board that's obviously got some wane still in it, or it's bowed or cupped this way, that's when I will use the bandsaw, because it's much better for those kind of still rough boards. So I'm going to be doing it both ways just to get these split without removing that much material on either side, so that if there is some kind of reaction with the wood that causes it to move, I won't have to remove as much material to fix it, and hopefully I won't lose some of these boards because they're just too thin. Well, that took a little bit longer than I expected, and after all that work, about a third of it done on the table saw, the rest on the bandsaw, I am now at the point where I was about 5 minutes after starting the hand tool version of this project. I've got roughed out straight boards, and it's at this point in time that I kind of start to duplicate what I was doing with my hand plane. At this point, I would flatten out one of the pieces, because after I sawed it off with that big block, it might have warped. Then I flipped it over. I used a marking gauge to find the exact height, length, width, thickness I wanted, and then I went across it with a hand plane to bring it down to that level, and planed it off. And in the video, you could actually see the mark I was planed down to, and when I started going with the grain with my hand plane, if you looked on the edge, you could see the little feathering of where my marking gauge was. And that took another 10 minutes or so for all 3 of those boards. It wasn't that big a deal. But now I've got to do the same thing on all of these, and it just doesn't make sense to do it in that method. So I'm going to the power tools again, and if you're flattening something, you're generally talking about the jointer. Now, a lot of people have this idea that power tools don't require as much skill, and I totally disagree. They require a different kind of skill. The jointer especially requires a type of touch, especially when you're planing thinner stuff like this. Let me explain. The idea behind the jointer is I'm running across a lower bed to a higher bed, and the machine is taking off the material to flatten it out. But if you think about it, if you have a board, this one is decidedly bent over, so you can see the gap in the middle. Well, this machine supposedly will remove that material from this side and this side until it brings it all the way down and is flat with this board right here. If I were to flip this board over, now all of a sudden it rocks. And it is possible for me to take an even amount off the entire board, so it's not bringing one section down or the other, and it's not bringing this down. I'm just kind of rolling it over the cutting edge and removing material. That's not dimensioning, that's just surfacing. I want to dimension. I want to get it flat. But the problem is, I now have a board that is so light and so thin that pressure can bring it down flat. So if I'm sitting here and pressing down across it to get it going, there's a chance I am once again just surfacing it, not dimensioning it, because I would force it down on those blades. So you actually have to kind of move it across without putting downward pressure. But then again, this thing is rotating and it's hitting the blade at an angle kind of coming back this way. So if I don't have any pressure down, it's going to pitch the whole thing off. If I have too little pressure down, it might slip out and I could hurt myself. So there's this balancing act of pressure that you use on this thing and where you apply the pressure. For example, if I had it cupped, I got it started going, I put all my pressure on this downside like I did, eventually this back end would be lifted up in the air and it wouldn't be touching the blade, and all I'd be doing is removing material on this side. If, for example, I ran it over and it's cupped high side like it should be, I come over and I don't have my pressure, it's going to hit this and stop. So there's a lot of variables here that you need to work with. Me personally, when I'm doing this lighter stuff, I'm going to be putting some pressure down, but I'm also going to be having something pushing this way so that my top hand is just keeping it so it doesn't bounce off of this blade, and the back is just pushing it across. So hopefully I will remove material here and here. There's also been instances where I will purposely, when I know it's not going to cut, start it here and just pull it across one way, flip it, pull it across the other way, just to remove the material on the ends until it gets close, and then taking full passes. I also like to keep a block plane available, because putting a little bevel on this end right here, when it is cupped, sometimes when you push it across, it'll hit that end, and if there's a slight bevel there, it'll pick it up on top and allow you to continue on, instead of just getting it stuck on sides that don't have a bevel. So right now, I'm going to go through that entire stack, and my only objective is to flatten one side of every single board. Or I should say, one face of every board. Now, because I'm using this tool as a dimensioning machine, I'm not really concerned with the surface. Granted, I don't want tear out, so I am looking at the grain to make sure I'm going with the grain, so it's not going to be lifting up fibers. But right now, I am actually contacting from here all the way across. I can run my fingers. There are still bandsaw marks and stuff throughout it, but right now, this is flat enough so it will fit on the surface of my thickness planer and it won't warp there. So at this point, I'm now done with my jointer because it will now run through my thickness planer and I can begin taking material off of both sides until I get not only the thickness I want, but a fairly nice finish. It's not going to be perfect out of the thickness planer, but I'm not concerned with perfect now, just a perfect dimension. Well, that took a lot longer than expected. Good majority of the day was spent, and all I did was put one flat edge on all of these boards. But I've got one nice dimensioned edge. Now, this is kind of one of those situations where my background as a hand tool woodworker is going to come out, because I really don't care about the thickness right now. In the plans, traditionally they were a 1/2 inch. If I'm close to that, I'm going to be happy. My key thing is I want this entire stack to be exactly the same because of this production run. That is much more of a priority to me than getting as many of them to the perfect 1/2 inch as possible, because I'm going to be putting them into jigs and stuff like that. So right now, it's just me pulling out the old lunch box and running them through, making a big mess, and getting them all exactly the same thickness, whatever it may be. Now, there are a lot of different techniques for determining how you use a thickness planer. Obviously, you're going to put your flat side down on the bed so it peels off the top to bring it down. And a lot of people will tell you, hey, you put it through one way on one time, put it through the opposite way the next time. That way you're taking an equal amount off. Me, I'm more of the get rid of the ugly style of user. Basically, I know that some of these are going to be perfect on one side because they just came off the jointer being a dimension flat. The other sides are going to have table saw marks, bandsaw marks, some pith or fuzziness or whatever. So if I'm always sticking the ugly side through, eventually I will get them all parallel, and if one side or the other at that point in time maybe has a little tear out, I'll just stick that through. Because if I keep getting rid of the ugly spots, hopefully by the end of the task I'll have good looking boards. So there we go. The thicknessing is now done. And if you notice a difference, I mean, this stack was all wobbly and stuff like that, but I think it's 20 deep now and it's pretty much dead even. The only difference is the sawdust that's in between these. And it's not a perfect inch. But I only took 2 passes on every single board. One pass leveled up with the bake side, and then I took a second pass just cleaning up whichever side was worse. As I said, doing the ugly side to make it pretty. But I don't want you to get hung up on that. This is dimensioning, and there was a time where I would waste so much of my days trying to get the finish just dead perfect in between stages. I mean, I'm not talking about sanding, but you know, I was worried, oh, there's tear out here, so I got to keep going a little bit more for the whole. No, don't waste your time. Remember, the last step is going to be the finishing. That's the only time you ever need to do that one. After all the joinery, after all the glue up in most cases, that's when you do the finishing. If you're doing anything else, you're just wasting time and losing labor in a batch out project. So, next up, we've got to 4 square them all the way around. Now, all of these boards right now are 2.5 or a little bit over 2.5 inches. And my final thickness is going to be 2 1/4. So I have a 1/4 inch to play with right here. So when you're doing your dimensioning, obviously we've got to get at least one of these straight, and that's what the jointer's for. And then I'm going to go to the table saw to rip it with this against the fence so that they will be parallel. But I first have to get one straight. So when you're doing this, you understand that the second step on the table saw is likely going to be removing the most wood. So if you have a big chip out, tear out, wane, or anything like that, leave that. Do the other side on the jointer. Also, at this time, be a nice finish. So it doesn't really matter, since these are now straight and parallel, which side you put on the jointer fence. So just make sure you're going with the grain, meaning the grain's going downhill and you're feeding into the blade, cutting it off. And also, verify that your fence is at 90 degrees. I find mine goes out all the time. I don't know if it's temperature changes causing the metal to move and the design of the carriage pushing it, but it's always going out. So at this point in time, it's got to be critical. Get it to 90 degrees. Also, just from maintenance wise, I think most people are going to be like me and they're going to have a jointer with blades on it. You might end up with a nick at one spot, and what I used to find is I always dull my blades over here. So when I'm doing thin stock like this, I'll go ahead and move my fence all the way over to a part of the blade I don't use that often, the far edge over here, and that way I will kind of dull this about equally all the way across. So after getting them all to an identical width, I went ahead and took the time and got them all to the same length. And that process was basically examining which area I wanted to take off the most amount of wood. Because remember, these were all about 2 inches more than I needed. And really the only thing interesting there was, real quickly, I use hot glue a lot when I'm doing jigs. Simply because I don't want to make a bunch of jigs. I don't have space around here and they cost money and time. So what a lot of times I'll do is I'll just put blue tape on the platform and blue tape on the jig, and in between those I will sandwich some hot glue. That way when I'm done with it, I can just peel off the blue tape, and nothing is damaged. I can use them for something else. Now, it is kind of nice being able to sit back after you've gotten all your parts dimensioned, make a big stack like this, and notice that everything is level, all the same length, just kind of a nice little setting. During that time, after I processed each one of them, I did divide them up. Basically, these are going to become the legs of my English square, and these are going to become the cross pieces. And the difference was, I wanted my legs to have as straight a grain as possible, so that I could orient it so that when people run their knife down, you're always laying the fiber down if you're starting from the opposite end and pulling towards you. Then I left the more colorful pieces, the ones with curls or nice figure that I liked, for that cross piece, because I think it will look a little bit more balanced, having generic grain on the outside and something wild in the middle. So now that we got all the pieces, let's start talking about design. There are a lot of different ways you can make stuff, and this is no exception. In fact, this was a very good teaching exercise for me when I was teaching lap joints, because an English square like this gives you the opportunity to practice the same joint on the front and back, because they are identical, and then they overlap. Just come down in here and you can do all that with a handsaw. Then it allows you to do an interior lap joint, practicing the same thing on the one that goes out, but on the inside you've got to use your saws, your planes, your chisels, all that kind of stuff. So it was just a great exercise to learn those skills. And the lap joint, I believe, is how Mr. Schwartz does it and how it was done traditionally. Just because it is a glue bond joint, but there is so much surface area when you do it that way, it's total overkill for this kind of application. In fact, I think you could get away with some biscuits and be perfectly fine for the lifetime of the tool. Now, on my personal ones, have never liked this look. I don't think it's uniform, and this tool is kind of a very balanced tool. Even on both sides, very symmetrical. So on my personal ones, I like to do some kind of mitre. And in the example I did with just hand tools, I did a bridle joint that was mitered. So only a quarter of it was the bridle joint, and then I put the miters on it. And then on the interior, I did a half lap, but I did the dovetail just because it'll give it a little bit more strength, I thought, if somebody ever tries to do this action. But the problem is, we are batching this out. If I do it this way in the production method, that basically means every one of these parts will be completely different. So I'll have to come up with 3 entire processes. And thinking down the line, that's just too much time. I would rather make one process for both of these legs that's pretty much identical, and then do a second process for this one right here. So this joint is not practical because each leg is different. So my thinking was to do this bridle kind of style, except have this tenon be a floating. A floating tenon is basically when you have 2 mortises and then a third piece of wood that glues into one side, then the other side, and when you bring them together, it kind of forms a tenon. It's just both sides of it are glued in. Well, I could do the same exact thing and drop a square piece in here that would be very easy to make. Then all I gotta do is put a tenon on both of these and then miter it. One step that would be identical for the entire either side. The other advantage of that is I don't have to be as precise in my measurement. As long as I get my bridle somewhat centered, it's going to be okay. So if I run this as cutting a mortise or a bridle on the table saw and just flip it and just make sure it's even, I can then size that internal piece, that piece I'm going to slide in, to whatever that gap is. So for the first step in the joinery, I'm going to create the slot for the floating tenon to fit into. Now, as I've said, there are a lot of different ways of doing any one task in woodworking. And if I was just doing one of these, I would more than likely grab a handsaw. I think in the video, just to demonstrate it, I used the bandsaw to cut out the bridle, the mortise of this joint. Before doing a large batch, I went ahead and took the time to make a little tenoning jig for my small table saw. And there is a video out there on how I did this. I published it last week. This will just greatly improve the speed that I can do all of those at once. Because if I was doing them all on the bandsaw, that would involve slicing it on one side, turning around, slicing it on the other side, and then having to clean up that center section. Many times when I'm doing that on the bandsaw, I just kind of angle it just to get rid of most of it and then hit it with a mortising chisel. Well, this way, it'll do all that in one step. Plus, I'll get a slightly cleaner shoulder so that it might look a little bit better, and I can size that floating tenon a lot more accurately. So the table saw for me is the best option. But the blade I have is basically just a combination blade. Every other tooth is slightly angled so that it can do both cross and rip cuts, and they end up with what they call bad ears, which means that whenever I make my cut, the kerf is going to come up, and then you're going to have these sections right here. That's where every alternating tooth cut, because they're at that slight angle. So somehow I've got to clean up that center section. So what I'm going to do is I'm going to cut this tenon. I'm going to cut it, I'm going to flip it, I'm going to make another cut. Now make it nice and balanced and centered. And there's a chance that I will move it over and I'll make a third cut right down the middle, just in an attempt to get rid of a little bit more of these bad ears. Now, the ideal situation would be that I would buy a very specific blade for this kind of cut. They call them flat bottom cuts, and they don't have those bad ears, and they're designed for ripping most of the time, or joinery. And there are several companies that make them, and you can even buy a single blade that's like a 1/4 inch or a 3/8 inch, so you just have one blade for very consistent cuts. And if I was ever to do this again, that would be a very good investment for me to make. They're a couple $100 many times, but it will save myself a little bit of time, and it will give me better results. So look for those bad ears as I cut through this, and understand, because I don't have the ideal blade, I have to compensate that with at least one more step. Now our next steps are going to require a lot of pre-thought. I mean, when I'm using my hand tools, I can kind of skip around, jump around, just do whatever I feel comes next. I'm only making one, and if I screw something up, it's never really that big a deal. But when you are doing dozens at a time, one mess up can cost you a lot of money, a lot of time. And if you don't do stuff in the right order, a lot of times you just end up duplicating your work. Frankly, it's a lot like chess. You've got to plan 6 or 7 moves in advance. And that's one thing I do like about production woodworking, because you do spend a lot of time doing repetitious work where you get to think things through in advance. You get to plan, in your mind, you get to analyze different situations. So, I want to lay out the situation for you and give you a little bit of time to think, what order of processes would you do? So right now we have all these boards. I just cut that bridle joint on the end, but I have not put the 45 degree on it. That's going to be one of the steps we do. So right now, theoretically, in a 2D world, we just have an 18-inch by 2.5-inch block. This is a shape that is traditionally done in this English square. We have the 45 degree bridle joint. We have a 1/2-inch recess from the top. The little decoration right here, the little OG, is about 1 inch by 1/2 inch down. It's a transition. You have a stepped OG right here. And you've got to do them, batch them out. Now when I do it by hand tools, I typically use my handsaw. I'll make a cut there, a cut there, and then I'll create a V cut, and then I will come down with either a handsaw or bandsaw and cut this entire section off. And that gives me the overall shape. The rest of this I can refine with files. This right here I can do with a coping saw. And I will take one regular back saw cut right down there to create that little step right there. And once again, the rest is done with files and sandpaper. But if I go in that order, that means this little doodad right there, I will have to do entirely with hand tools on every single one. I don't want to do that one. But I also know that shape right there is going to require some handwork. So I want to get as much of the shaping done as possible with power tools and do them all batched at the same time. So I'm looking at that shape right there. That is going to be our biggest obstacle. So pause this video real quickly, and I want you to think, how would you create that shape if you wanted to batch them out? Now my thinking is the biggest volume of material I need to remove is this section right here. So if I have my board and I just create a U until I hit my depth, at that point I can do all the other work on a table saw and with a chisel, because this direction right here is going downhill. That is a very easy one swipe with a chisel, just curve it over. Same with this right here. And all that is left is a table saw cut and a table saw cut basically cutting that curve down to the point where I want it to be. A table saw cut over here, and then I just have my 2 chisel cuts to round it over. That is the best, least amount of work method I have come up with to create that shape. And I can do this U on the router table, either singly or a dozen of them. And I'm going to create a quick jig to do a dozen at a time, because I am worried that the router bit, if I do them one at a time, will blow out all the edges. But if I can smash a bunch of boards together and cut them all at once, I really only have to worry about blowout on the very last one. That could be a sacrificial one. So my next step is to create a simple jig that can hold a dozen of these boards at once, and then just like somebody would flatten a long slab with a router, I'll create a sled that goes over on top that will lock down into this position. Another advantage of this setup is that I can now use that same exact jig, that same exact sled, to create the dual little finials on, or OGs, on the cross piece. All I have to do is figure out how to move the sled over a little bit. Now that we've got all the grooves cut for the OG, basically all I gotta do is concentrate on the table saw for a few hours, cutting the deep side that's going to go for the full 1/2 inch, and the inside, which is just going to nick it a little bit so I can have a place for my chisel to go. But I'm purposely leaving the end square for now, for the simple reason it will make my chisel work a lot easier rounding over that top of the OG, because I can bump it up against something and put pressure on them. And doing them one at a time without having to clamp each individual one separately will just save time over the long run. After about an hour spent chiseling out the little domes on the OGs, I realized how long it would take me to get the entire stack done. We're talking days of work. And then I recollect that I had my dad's old scroll saw. He never really used it. He loaned it to me, and I never really gave it back, but he hasn't asked for it. So I'm going to try that out, and I believe after only 20 minutes of work that this is going to be much, much faster, and I'll be able to finish this entire stack today. The scroll saw is just one of those tools that is really, really flexible, and if you're in a small shop, you can build quite a lot with it, and they don't seem to make that much dust on them, or the dust they make falls down fairly close by. But even though it's so flexible, it's one of those tools that I forget about using as often. But if you're in a small shop, hey, you want to use as much as you possibly can to get the work done. And it just might be the perfect solution for what I'm doing right here. Quick cuts, maybe a minute on each one. This will be knocked out in a day. And just like that, I got some OGs. Now the process of creating the rest of the shaping of these legs could be daunting, especially if you're time conscious in the production run. So what I did was I created a jig, some way to hold a master template that has the exact shape I want, and then I could put the individual pieces I cut out and then bring it over to my router table and route out the shape. Basically duplicate the master with my other legs. The thing is though, I've always found that when I'm doing this one, I don't want to be removing that much material. If you're having to remove a whole bunch, then the router bit is doing a lot of work. Now what I'm using today, I believe is called a patterns maker's bit. And basically they come with bearings either on top or bottom or both, as I have right here. And this will allow you to have a master shape that you can duplicate on the other stuff around it, because I can basically ride that on the bit. Now if you understand routers, in my experience, they don't like to take off a lot of wood. When you do, those shavings build up in here, it creates a lot of friction and you get burning.
If you can take off as little amount of wood as possible with the router, you generally get lower temperatures, less chance of burning, and a lot of times a better finish, because if you're taking off a lot, there's a better chance that it's going to chip out or split off. So what I've done is on all of these templates, you saw me earlier on the bandsaw cutting off a long section, and that would leave just enough, maybe a 1/16 of an inch, for me to remove in this router template jig. I also cut off the end. My pattern is basically I will undo my locks, put in a blank for me to put the master on top, clamp it down, go to the bandsaw, cut the shape out, and then come to the router. And I'm going to make two types of cuts when I do that one. The first cut is actually, a lot of people would call it a somewhat dangerous cut. It's what they call a climb cut. If you understand routers, they spin clockwise, but when you put them upside down, in a router table, they're going to spin counterclockwise. So it spins in this direction. And the general rule of thumb in hand woodworking, when you're moving it by hand, is you want to go into the blade. That way you're always feeding into it and there's no chance it's going to grab. If you go with the circulation, if I were to move the board this way, there's a chance that that blade could bite in the wood and then rip it out from my hands and drag it forward, what they call running. But every CNC woodworker will tell you, you get a better finish when you're doing what they call a climb cut, that more dangerous cut. Because the shavings are coming off, it's shaving off, and it's more going with the grain when you're doing that. If I'm going this way, it's actually chipping it out. If I'm coming this way, it's kind of pushing it down. So there's a better finish. But I don't want to risk doing that same thing on the end, because if I was doing a climb cut and coming this way, well, this wood the grain is very likely to split. I want to lay those fibers down. So I'm going to make a regular cut on the end just to make that shape, to avoid having the end grain split out with a climb cut.
Now, if I'm being upfront with you, this is actually the second one of these jigs I made. Why? Because I can be very, very stupid sometimes. Here's the first one I made. Take a look at it. You tell me what the major fatal flaw in this design is. Yep, this land right here. Remember, if the wood's if it's in a table saw, it's going to be spinning upside down. So the blade would have been coming this way, hitting those fibers and chipping them out. It would have split those up. The end grain would have been all torn out. It would have been horrible. I actually needed to have it the other way, which is how I designed this one. Because now that counterclock rotation will be laying those fibers down, and it's not going against this end grain, which is so easy to split. So yes, I can be stupid sometimes. Quite often, actually. So that leaves the last step, is to cutting the mitre on each one of these so that they will form RA before we begin gluing up steps. Now the common sense thing was, because I cut this on the table saw, that is a perfect square, so you would think that all I would do is cut a mitre so it would hit down on the end of this thing right here, the base of the bridle. But I'm going to do something a little bit different. I'm actually going to come down into the wood a little bit lower than the bridle on my cuts. And while I set up the jig and show you how I make those cuts, I want you to think, why am I doing that? After I do them, I'll explain. So it's time that I want to start gluing up the A-frame section. I'm doing that one because I want to have the A-frame glued so that I can fit that cross piece, because I'm worried that there might be some variations in all my machining and stuff like that. Human fault, variations come in. So what I've done right now is I've set up a quick little jig on my workbench. I've got 2 pieces straight edges, and they're set so that an other square that I have, I'm just using an English square, but you can do anything, even a piece of MDF, sits in and it's flush all the way around. And this will be a nice glue up jig. And yes, I did check this before I'd set the jig up. Using a long straight edge on a piece of MDF, and I just drew a line, flipped it, and made sure that the lines lined up. If that's the case, you got a perfect 90 degrees. And with this setup, I can just grab 2 legs, bring them together where they touch, and that'll form a nice 90 degrees so that I know at least my glue up will be 90 degrees. Now here's why I made that undercut, where you could see a little bit of that edge right there. Because when they come together, if there was any variation, you know, even a slightest bit of a millimeter, especially with those bat ears, you would see the cut right there. And I wanted them to join up really, really smoothly, no matter how my cuts varied. Plus, you know there's going to be glue squeeze out. So if I have that little solid piece right on the edge where they come together, that should prevent a little bit of this glue squeeze out coming out right there. And speaking of glue squeeze out, I've cut these little pieces to go into the slot. Slides right in there. But if I have a perfect square, yes, it's going to bottom out, but I'm not 100% sure that it will bottom out on these corner sides. So what I have done is I've taken all of these and still had the square on one edge, but on the interior I recessed it to create a slight diamond. That way I know that these 2 corners can touch on the end, but there'll be a little bit of a space along this side that not only glue can sit in, but it'll allow me the flexibility to move this around to make sure it really fits in tight on the show sides. Another reason for timing this glue up at this point in time is that's really all the number of clamps I have that's applicable for this situation. Just something small that I'll clamp it down in here. Now it is over 100 degrees here in Texas, so it won't take too much for this to tack up. You know, you still want to leave it for 24 hours before you do anything drastic with it, but to tack up so I could take a clamp off. So I could actually glue up 6 of them at a time and then go work on that cross member, whether it be making cuts, cutting tenon cheeks, or designing jigs. You know, each one of those steps might be an hour. So in between those steps on working on that cross member, I'll just come glue up another 6. So by the time I get all those cross pieces ready to rock and roll, I should be able to return and work on these to cut out the recess. Now getting rid of the waste after the OGs on the legs was really fairly simple. I mean, get rid of most of it on the bandsaw and use that router template jig to finish it up. Not so much on these center stretching, the center pieces. So on that one, I'm still going to use a router, but I'm going to have to do it in multiple passes per leg. And basically what I've done is I've set up 2 stops on either end of my router table that correspond where I want the router bit to stop on each side, and I have it going up to the depth that I want. I'm just going to make multiple passes on one side, flip it, do the other side, do the whole batch, and then clean up that center section with a final pass. And that should give me a fairly smooth finish, but because it's using the top of the bit and not the sides, and it's not ever going into end grain, I shouldn't get any burning, and it should come out pretty smooth right off the bit. So that's how I'm going to get rid of the center section on these center stretchers, using the router table, but coming at it from the side instead of the end. Now, one thing I've learned in my woodworking is never trust your rulers or gauges or anything like that. Your best gauge is always going to be your fingers. For example, I did all of these, I cut one tenon off, and then I got to go do the other one. But in order to do that with my jig, I have to move the fence, which means I have to set this side perfectly to this side. Now, the easiest way I do it is I'll measure as best I can with rulers and such, but then I will feel. After I cut the new side, I'll bring it over to the side I want to get level to, and I'll just run my finger over it. And when I can't feel a difference, I know it's dialed in. It took me a few trials, even though my rulers were showing me I was accurate, until I got a smooth crossover. Now, I didn't deem it necessary to show you all the steps I used to cut these tenons out, because basically it was just repeating the same things. A little hot glue, tape, adding in a 45 degree, but that was about it. You see me do it earlier in the video. But I do want to point out, the thickness of my tenons is not half. It's actually probably less than a third, and you'll understand why later on. But right now I am coming up to the part of this build that I've dreaded the most, because no matter how accurately I try to make stuff, no matter how much my jigs are set up, inaccuracies creep in. And not only do they creep in, they build. Here's what I'm talking about. This section right here, that was from my original dimensioning. And those were all very, very accurate. But as I progressed through this, even though I was using jigs and copiers and stuff like that, this right here, it might be slightly different on some of them than the others. Maybe a piece of shavings got in between the frame of the jig and the board and I didn't notice it. Maybe my skill of using the tool wasn't as good. Maybe my tools had some variables. For example, that job site saw. The blade, it doesn't cut a straight line. Yeah, they look straight, but if you ever put two straight lines next to each other, you'll notice little gaps here and there. It's just the nature of a job site saw. It's not the best for this kind of application. Well, all those inaccuracies creep in. And I think this is the same in any kind of production run. The farther down in the production processes is, your tolerances get a little bit less. And the biggest difference I found is, even though I've got this glue up jig set up just at 90 degrees, as things dry, maybe they get jostled for whatever reason, it might be a quarter of a degree off. And you really never true these things up until you're totally complete. Well, these right here, they've got the 45 degrees. They're designed to sit in here and fit nice and snug so we have no gaps. But if this angle is a little bit off, or if this thickness is a little bit off, well, all of these will sit ever so slightly differently. And a half a millimeter's difference, one way or the other, will show up as gaps and it just won't fit right. So what I've been dreading this entire time is designing a setup, designing a process in this last step where I can cut out the recess for these tenons and the mitre lap joint on the sides so that it will fit snugly, but have some way to vary it for any inconsistencies that have crept into the process. Now, what I know is this width right here is going to be very, very consistent. That was one of the first steps in dimensioning, and that has not changed since the very beginning. It's the location of that along the legs that's going to be the variable. So, just like we did earlier before, you've seen me use table saws, routers. You've pretty much seen all the tools I have in my shop. How would you compensate for any kind of inconsistencies in designing a jig to cut out these recesses so that they can be done in a timely manner? I mean, when I was doing hand tools, it was really, really simple. I literally just placed it where I wanted it on the A-frame, used a knife line, hand cut to the line, and chiseled out the waste. 10 minutes worth of work, maybe. But doing that 10 minutes worth of work, 300 times is not feasible. So I've got to use jigs and power tools. So take a break here, ponder, how would you design the jig to compensate for those inconsistencies? And when you come back and see how I did it, maybe if it's different, or if your way is better, leave those comments down below so that other people can learn. Anyways, I've got to make a jig to get this thing rocking and rolling. Now, cutting the dadodes for this to fit into has been really my biggest obstacle. And I hate to say it, for me it really has been paralysis by analysis. I have been dreading this step because, I mean, I could ruin everything in just this last pass. And because of all those variables, I know it'd be very hard to get it off right there. So what I've been doing is I've kind of understood from the get-go I'm going to be using some kind of router sled. I mean, it's just the best tool out there for it. So it wasn't that hard for me to take some of the pieces that I had messed up for one reason or another. Maybe they got a big tear out, or I didn't do anything, but it was based on that initial dimensioning. So that they're all exactly the same height. Just create a jig that would hold one of these pieces in the A-frame, so it's not going to be moving around. And because it's all even, I can make some kind of jig where I would slide a router sled. And I replaced the standard plastic base with one that's really long so that it would span across both legs and I could move it around to get the even setup. But what's driven me to paralysis is I was stressing that I had to know exactly this thing's what measurements, and in order to get it centered I would have to do all that kind of stuff, so there's a lot of precision here. Then I had to make sure that the bit measurement from the edge is exactly a certain distance, and then figure out that distance so that from both sides, so that I would only be cutting this much out and it would be all aligned individually. That was a lot of math. That was a lot of measurements. That was just a lot of stressing and so many places where I could get stuff wrong. So it really did come down to, my solutions come down to me falling back to what I did with the hand tool. I literally put this right against the wood, took my knife and measured it. The only thing I want to eliminate is using the knife aspect. So my solution was to say, screw the rulers. Starting with the router, I no longer cared if it was centered. I basically cut a piece of MDF on the table saw, so I know that these two are parallel. That's really all I cared about. Then I just placed this roughly in the middle, and using the old plastic one, I just drilled 4 holes and mounted it on there. I used a Forstner bit to cut out a rough hole, and there we go. I now have a sled that will slide along the level areas. Next, I cut out a couple more pieces of MDF, and because I did on the table saw, I can rest assured that they are at least parallel. The width is just the length of this jig. Now, if I ever run this against the jig, all I really need to do is figure out what the distance is between the cutting edge of the router bit and this side right here. And because it is not centered or anything like that, I want to make sure that this is always referencing this larger fence. How can I do that measurement? Just cut a piece. I've got an offcut that's a tad bit too big. You can see that the router bit is going to cut into it a little bit. I braced a piece of wood right here, clamp that up to my workbench, and trim off just a tad bit so that the end result, the offcut, is the exact size we need. Over at the table saw, I can use those 2 saw cuts to set up the fence and basically make a custom size sleeve so what I end up with is a back piece that lines up, a top piece that lines up, and they end up being the perfect size for this right here. So that right there is the gap in my drill bit. So really, all I now need to do is put in a spacer of whatever in between those two, and I can cut out a perfect sizing of whatever I put in between them. So what I end up with is a sandwich. I have my top fence and my bottom fence. I have the space in between the front of the drill bit and the back of the drill bit, and then I have my cross piece that I'm going to want to dadoed out. So this sandwich right here, if I screw these two fences together, that will give me the perfect sizing to use my router sled. The question now is, how am I going to size it to accommodate for all the variances, because this cross member might be in a slightly different position on every single A-frame. But we're only talking maybe a few half millimeters. So here's how the whole setup's going to work. I have my A-frames that are glued together. I can drop them in and secure them so that they aren't moving anywhere. I then have my frame. I come over here making sure that the arrows, the thick part, are up front. Just drop that on. Then I take my cross piece. I put it on the wood, and because it's got that mortise on it, it's going to find a spot where it likes to go. Then I take that front measurement piece, I drop that into my jig. I can bring everything down so it rests now on the cross piece that is perfectly mated to its A-frame. And from there, it's just a matter of clamping up the sides, removing both the cross piece and the spacer. I'm going to drop in an equally sized piece just for the router to ride on as I do each opposing side. And then making sure that the router fence is going with the section right there, starting in the middle and routing out the rest. Climbing cut, just removing that little bit of material. Nice and flush on both sides. Now here's the big thing. How's it look on this side? Gaps are pretty good. That was the first try on this jig, and I think I can even make it a tad bit tighter on this top section right there. Maybe a little blue tape will take care of that. I'm pretty happy with that. I mean, it'll make a really nice tool, and all that's left is a lot of cosmetic stuff. I'll use a flush trim bit to take care of these excesses on either side after gluing this centerpiece in. Then I'll run it through the drum sander to get that final little sanding done. Then after that, it's just spending about 5 minutes on each one of them and doing their make nice, make pretty. Just checking everything to make sure it's ready for the customer. I'll probably throw a little oil on it at that time, let it sit for a day or two, then drop them in the mail. But before I can do any of that, I'm going to have to spend 5 or 6 hours cutting out all these dados. Well, I think I'm going to call it right there. This video is getting long enough as is, and it's going to probably take 8 to 12 hours for this video to render, another 4 to 6 for it actually to get uploaded to YouTube. So while that's happening, I can finish assembling all of these for the next sale. Now, I hope you paid attention. Really, this project was somewhat irrelevant. It was more the mindset, the thought processes that you're doing whenever you're batching stuff out using power tools. And in my mind, that is what a power tool excels at. Really batching stuff out. Being able to set a jig up and then spending 4, 6, 8 hours not changing the jig and just running stuff through. There's no way you could produce as much as you can with hand tools as you can with power tools in that kind of situation. But if you're only making one item, I think I showed you in the last video, and you saw in this video that a lot of times it's much quicker just to grab a saw, draw a line, and saw to the line. That's all I did making that first one. Making just one of these required me to make all of these jigs. But now that I've got these jigs, it doesn't require that much more effort for me to make 10, 20, or 100. I'm going to end up with probably 35 or 40 of these items in this first batch. And it took me quite a few days to do that, but I was making jigs. The next time I come into the situation, I can just pull out these jigs, run them through, and might be able to get 100 done in the same amount of time it took me to make these less than 40. And that just is a great example of using power tools for what they're meant for. It's just an entirely different skill set, but the thought processes, the techniques, the kind of stuff you do, really do translate between the two. Well, I hope you enjoyed this video. Maybe you learned a few tips or techniques out of that one. If you did, you could do me a big favor. Like, favorite, subscribe, do all those social medias, tell your friends. And if you want to see what the finished product of these looks like, visit my Instagram. I'll probably have a whole selection of them out there. Or if you want to buy one of these. Yeah, I know it makes no sense whatsoever. Not only did I show you how to make one with hand tools, I then showed you how to make an entire set yourself, or the processes you could do with the hand tools to make one on your own, and then I'm asking you to buy one from me. But as I said in the beginning, it really isn't the product that's the lesson. It was the process. And if you want to support the channel, maybe consider visiting my website, where not only do I have English squares like this, I also have the dovetail markers, French squares, and a lot of my own artwork, such as bowls, boxes, and stuff like that. All of those sales really do help support this school or channel, and really it just kind of buys the supplies for me to make these videos for you. And once again, thanks for watching, and I want you to remember one last thing, that it is always worth the effort to learn, create, and share with others. Y'all be safe and have fun.